So in the last video we have studied about two rules to reduce the inexact differential equations to the exact differential equations. So now we will move forward to the rule 3, 4 and 5. So rule 3 says if m is the form of m is equal to y into f1 xy. Do not confuse between y and f. My f and y is a little bit of similar, so let me give it a stroke so you can clearly understand this. So y into f1 of f1 is a function of x and y, and n is in the form of x into f2, which is a function of x and y. So the integrating factor here will be 1 by mx minus ny. So why not take an example to clearly understand this. So y into xy plus 2x square y square into dx plus x xy minus x square y square into dy is equal to 0. So let's divide xy both sides. So we will get that y into 1 plus 2xy dx plus x into 1 minus xy dy is equal to 0. So we made this equation a little bit of easy to understand. We have reduced some terms. So now we get that m here is y into f1 xy. This is y and this is f1 xy, and n is x into f2 xy. So x into f2 xy. So we got our general form. So now the integrating factor will be 1 by mx minus ny, that is 1 by xy into 1 plus 2xy minus xy into 1 minus xy, which will be equal to 1 by, let's multiply this, plus 2x square y square minus xy plus x square y square. So now this cancels, so now we have 3x square y square. So our integrating factor here is 1 by 3x square into y square. Now we have to multiply to the equation this. So 1 by 3x square y square multiplied by y into 1 plus 2xy, y into 1 plus 2xy dx plus x into 1 minus xy dy is equal to 0. Now that becomes y plus 2xy divided by 3x square y square dx plus x minus x square y divided by 3x square y square dy is equal to 0. That implies y dx divided by 3x square y square plus 2xy dx divided by 3x square y square plus x dy divided by 3x square y square minus x square y dy divided by 3x square y square is equal to 0. That implies dx by 3x square y plus 2 dx divided by 3xy plus dy by 3xy square minus dy by 3y is equal to 0, right? So we got dx into 1 by 3x square y plus 2 by 3x. I have made a little bit of mistake here. This becomes 2xy square as the y is multiplied by this term. So we get here y square and we get here 2 by 3x. So 1 by 3x square y plus 2 by 3x into dx plus dy into 1 by 3x y square minus 1 by 3y is equal to 0. So now we have, this is m and this is n, and we have this equation as exact equation, so we can solve to our previous rule, that is if we apply this, so it becomes 1 by the m term 1 by 3x square y plus 2 by 3x into dx, where y is constant, plus the terms not containing the x term, so this is not considered, this is only considered, so that is minus 1 by 3y dy, their integration is a constant. So if we solve this, that becomes 1 by 3x square dx. Here 1 by y is outside because we treat the y as the constant, and we can also take this take the 3 here also. So 1 by x square dx plus 2 by 3 dx by x, that is minus 1 by 3 into dy by y is equal to c. That is 1 by 3y, this becomes minus 1 by x, plus this becomes 2 by 3 ln x minus 1 by 3 ln y is equal to c. So this is the final answer we get after solving the differential equation. Now we will move forward to the rule 4. Rule 4 says, if something like x to the power m y to the power n into ay dx plus bx dy plus x to the power m dash y to the power n dash a dash y dx plus b dash x dy is equal to 0, then the integrating factor will be x to the power h and y to the power k. And also there is also a condition, that is m plus h plus 1 divided by a is equal to n plus k plus 1 divided by b, and m dash plus h plus 1 divided by a dash, that is equal with n dash plus k plus 1 divided by b dash. So we have a little big formula and condition here. So let's take an example. So the example is y cube minus 2x square y into dx plus 2xy square minus x cube dy is equal to 0. So we have to bring into this form, right? Let's open the brackets here. So y cube into dx minus 2x square y into dx plus 2xy square dy minus x cube dy is equal to 0. And let's bring this term and this term together, and this term and this term together. So we can get y cube dx plus 2xy square dy minus 2x square y dx plus x cube dy is equal to 0. So let's take y square here common. that becomes dx y dx plus 2x dy minus, and let's take x square here common, so that will become 2y dx plus x dy is equal to 0. And also let's do one thing, let's multiply this minus in the bracket. So y square y dx plus 2x dy plus x square minus 2y dx minus x dy is equal to 0. So here this equation is similar with our general form. How? Because for the x to the power m y to the power n, we have x to the power 0 and y square. So x to the power m, y to the power n. Here m is 0, n is 2, and y dx plus x dy, ay dx and bx dy. So here a is 1 and b is 2. Exactly like this. Here we have x to the power m dash and n dash. So m dash is 2 and n dash here will be y to the power 0 as 0, and here a, right, a dash and b dash. So a dash here is minus 2 and b dash here is minus 1. So we get the similarity with our original equation. Now how we can solve this? So let's write it up. So m is 0, n is 2, a is 1, b is 2, m dash is 2, n dash is 0, a dash is equal to minus 2 and b dash is minus 1. We will use this condition and this condition to find the value of h and k. So 0 plus h plus 1 divided by 1 is equal to 2 plus k plus 1 divided by 2, and 2 plus h plus 1 divided by minus 2, that is equal to 0 plus k plus 1 divided by minus 1. So now it is h plus 1 is equal to 3, this becomes 3, right? 3 plus k by 2, and 3 plus h by minus 2, that is equal with minus k minus 1, minus k minus 1, the 1 disappears. So 2h plus 2 is equal to 3 plus k, that is 2h minus k is equal to 1, and 3 plus h is equal to 2k plus 2, that is h minus 2k is equal to minus 1. So we will solve this, right? So let's solve this two equation. Let's multiply 2 here and 1 here, right, both sides. So it becomes 2h minus k is equal to 1, and this becomes 2h minus 4k is equal to minus 2. So let's subtract this. So this becomes 0, and this becomes minus k plus 4k is equal to 1 minus minus 2, that is 3k is equal to 3 and k is equal to 1. If k equal to 1, so here h minus 2 into 1 is equal to minus 1, that is h is equal to 2 minus 1, that is h is also equal to 1. So we got h equal to 1 and k equal to 1. So our integrating factor is x to the power h and y to the power k, so that is x to the power 1 y to the power 1, that is xy. So let's multiply the integrating factor with our original equation. that is xy multiplied by y cube minus 2x square y dx plus xy into 2xy square minus xy dy x cube dy, that is equal to 0. So this was our original equation. We have multiplied xy with this, right? So now that becomes xy to the power 4 minus 2x cube y square dx plus 2x square y cube minus x to the power 4 y into dy is equal to 0. So this is an exact equation, so we can use the formula directly. Xy to the power 4 minus 2x cube y square dx, where y is constant. By the way, this is m and this is n, right? And plus the terms not containing the x. Here this term also contain x and also this contain x, so we will omit the whole n term. Plus 0 is equal to c. That is y to the power 4 x dx minus 2y square x cube dx is equal to c. That is equal with y to the power 4 x square by 2 minus 2 y square x to the power 4 by 4 is equal to c. That is x square y to the power 4 divided by 2 minus x4 y square divided by 2 is equal to c. So this is our final equation after the solving inexact differential equation by reducing it into the differential equation that is in exact form, right? And finally we will go to the rule 5, which says if the equation is in the form mdx plus ndy is equal to 0, is a homogeneous equation and mx plus ny is not equal to 0, then the integrating factor becomes 1 by mx plus ny. We have studied mx minus ny. Here it is the case of mx plus ny. So let's take an example, that is dy by dx is equal to x cube plus y cube divided by xy square. So it becomes x cube plus y cube dx plus xy square dy is equal to 0. Oh sorry, this becomes equal, right? Sorry. So x cube plus y cube dx minus xy square dy is equal to 0 is our final general form, right? So this equation is homogeneous as each term has a power of 3. This has a power of 3, this has a power of 3, and this has power of 3, as x has power of 1 and y has 2. So this becomes, the whole power is 3. So this is a homogeneous equation. So our first condition is satisfied, the equation should be homogeneous. And now let's test this. Mx plus ny is not equal to 0. So here m is x cube plus y cube and n is minus xy square. So mx will be x to the power 4 plus xy cube and ny is equal to minus xy cube. So mx plus ny is x to the power 4 plus xy cube minus xy cube is equal to, so becomes x to the power 4, which is not equal to 0. So our second condition is also satisfied, our first condition is satisfied. So our integrating factor will be 1 by mx plus ny. So integrating factor becomes 1 by mx plus ny, which is 1 by x to the power 4. So multiplying 1 by x to the power 4 with our original equation, that is, let me copy this. Right, so 1 by x plus y cube by x to the power 4 dx minus y square divided by x cube dy is equal to 0. So this is m, this is n. So let's do our thing by solving the equation, that is 1 by x dx plus y cube by x to the power 4 dx, both have y equal to constant, and this term cannot be taken as it has an x term, so it is equal with a constant. So ln x plus x y cube 1 by x to the power 4 dx is equal to c, that is ln x plus y cube x to the power minus 4 dx, that is ln x plus y cube x to the power minus 4 plus 1 divided by minus 4 plus 1 is equal to 0, that is ln x plus y cube x to the power minus 3 divided by minus 3 is equal to 0. Hence ln x plus minus y cube by 3x cube is equal to 0. Oh sorry, we have this is constant, I'm really sorry. So this is our final answer to the differential equation, and we have solved every type of first order differential equation, and in the next class we will move forward to the higher order differential equation and how to solve them with different types of methods. Thank you.